morning, everybody. In last class, we were discuss about the atomic and ionic radii, then ionization enthalpy of G16 elements. What is atomic radii? The distance between center of nuclei to the any point on last cell of atom of element is called as atomic radii. The atomic radii increases down the group with increase in quantum cells, but along the period it becomes decreases. That will be discussed. Then ionization enthalpy, second point. What about the ionization enthalpy? The amount of energy required to release the number of electrons present in different cells around the nucleus is called as ionization enthalpy. And what is the trend? The ionization enthalpy value of all G16 element possess high, but the ionization enthalpy value is decreases down the group from oxygen to polonium. Why it is decreases? Because it is due to increase in atomic size. We know the atomic size increases from oxygen to polonium. Therefore, ionization enthalpy value is decreases. But along the periods or across the period, the ionization enthalpy value becomes increases. Along the period or across the period, ionization enthalpy value is increases. It is due to increase in nuclear charge and atomic number. What? The ionization enthalpy value increases along the period. Means what? The ionization enthalpy of G16 is greater than G15, but not. That is exception. The ionization enthalpy of G16 is less than that of G15. Trend is increases, but the ionization enthalpy value of G16 is less than G15. It is due to half filled orbitals, p orbitals of the G15 elements. G15 elements can get the stability due to its half filled nature of the p orbital. So it is the trend. So in this class we are going to discuss the third point or third question for the 2 marks, that is the electronegativity of G16 elements. What? Electronegativity of G16 elements. So question may be, explain electronegativity of G16 elements can ask. Then how to write the answer of this question? Third question, electronegativity of G16 elements. We know that all p block elements are electronegative. In periodic table, the elements are placed in left, that is S block elements, right in p block elements. P block elements are highly electronegative. Why? Because all these p block elements have tendency to guess the electron and complete their octet. Therefore, it can behave the electronegativity. G16 elements have tendency to gain electron. G16 elements have tendency to gain electron to complete octet and shows electronegativity. But what is the actual trend? What is the actual trend of G16 elements from oxygen to polonium. From oxygen to polonium, what is the actual trend of that Z16 elements? In Z16 elements, electronegativity decreases down group from oxygen to polonium. Electronegativity of this 16 element is decreases down the group. It is due to increase in atomic size. We know from oxygen to polonium atomic size increases. By increasing atomic size, its electronegativity decreases. But across the period, electronegativity increases. Electronegativity of these 16 elements along the period or across the period can be increases. It is due to increase in effective nuclear charge. When we are moving from left to right along the periods, the effective nuclear charge increases. Therefore, electronegativity can also increases. In Z16 elements, oxygen, that is the first element, oxygen can shows higher electronegativity. In the 16 element, oxygen shows the higher electronegativity. And last point, the oxygen have more electronegativity than fluorine of G17 element. Actually, we know the electronegativity across the period is increases, but in exception case, the electronegativity of oxygen is more than that of the fluorine of the G17 elements. Then see the chart. These are the elements and electronegativity of G16 elements. In G16 elements, first is the oxygen, then sulfur, selenium, tellurium and polonium. All these 5 elements are included in G16 elements. The electronegativity of oxygen is 3.50, that is 3.5. Then sulfur 2.44. Electronegativity of sulfur is 2.44. Then 2.48. Then 2.01 of the tellurium, and last of the polonium 1.76. Means what? This table can shows the electronegativity of G16 element is decreases. Highest electronegativity of oxygen is 3.5 and lowest electronegativity of polonium is 1.76. So this is the electronegativity of G16 element. What is the trend? In G16 element, electronegativity decreases down the group. Why? It is due to increase in atomic size. Across the period, electronegativity increases. due to increase in effective nuclear charge. In Z16, oxygen possesses higher electronegativity, that is 3.5, but the electronegativity of oxygen is more than that of the fluorine of Z17 elements. So this is the electronegativity. After that, to the next point, that is electron gain enthalpy. Electron gain enthalpy of Z16 elements. Electron gain enthalpy. Next point, electron gain enthalpy of Z16 elements. So first of all, is the definition of electron gain enthalpy. We know that all p block elements are the highly electronegative. It have tendency to gain the electron for the completion of octet. So what is the electron gain enthalpy? The amount of energy required to complete to gain electron for completion of octet is called as electron gain enthalpy. Generally, from G13 to G18, all these elements have tendency to gain the electron for the completion of octet. Only the 18 elements becomes completed their octet, but other elements have tendency to gain electron. So that the amount of energy required to gain electron for completion of octet, that is stability, it's called as electron gain enthalpy. Then see what is actual trend of electron gain enthalpy of Z16 elements. In Z16 elements, electron gain enthalpy becomes less negative down the group. In the 16 elements, the electron gain enthalpy becomes less negative down the group. It is due to decrease in ionization enthalpy value. It is due to decrease in ionization enthalpy value in down group. Down the group, ionization enthalpy value decreases. Therefore, the electron gain enthalpy value is less negative from oxygen to polonium. Then the electron gain enthalpy, of Z16 elements possess less negative. All the G16 elements can possess the less negative electron gain enthalpy value, but in Z16 oxygen have less electron gain enthalpy electron gain enthalpy than sulfur. Oxygen gain enthalpy of oxygen is less negative than that of the sulfur. So what is the actual trend? The elements and electron gain enthalpy of Z60 element. First element is the oxygen, then sulfur, selenium, tellurium and polonium. All these elements can possess the negative electron gain enthalpy. Oxygen can possess minus 141. Electron gain enthalpy of oxygen is 141. Then sulfur can possess 200. Electron gain enthalpy minus 200. Then minus 195 of the selenium and tellurium minus 190. Tellurium can possess the minus 190 and last one is the 174. So this is the electron gain enthalpy trend of all the 16 elements. Oxygen possess minus 141, sulfur possess minus 200, then selenium minus 195, tellurium minus 190 and last one is the polonium can possess minus 174. So this is the electron gain enthalpy of all elements which are included in Z60. Then next question for 2 marks, that is the physical properties of Z16 elements. Physical properties of Z16 elements. Next, 5th question. Physical properties of Z16. Physical properties of Z16. We know the Z16 elements are the oxygen, sulfur, selenium, tellurium and polonium. So which points are included in physical properties? First point in Z16 only oxygen is gas. Only oxygen is gas, while other elements are solid at room temperature. These are the 16 elements: oxygen, sulfur, selenium, tellurium and polonium. But in these elements only oxygen is gas, but remaining all elements are solids at the room temperature. Whenever the room temperature is considered, at that times only oxygen is gas. Then second point, in G16 elements, oxygen and sulfur are non-metals. Oxygen and sulfur are non-metals. Then selenium and tellurium in G16, selenium and tellurium are metalloids. But only polonium in G16 is metal. Means what? In G16 elements, the elements from oxygen to polonium, oxygen and sulfur are the non-metals. Then selenium and tellurium are the metalloids. Means what? Can possess the both properties of metal and non-metal, and only the polonium is metal. In G16 elements, polonium is radioactive element. polonium is radioactive element having half-life period 13.8 years. The half-life period of polonium is 13.8 years. Means to what? The polonium can reduce to half, disintegrate to half. It required the 13.18 years time period. So it is only the radioactive element. In these 16 elements, melting and boiling point can increases down the group. Whenever we can move from oxygen to polonium, the melting and boiling point increases down the group. When we move from oxygen to polonium, then its melting and boiling point can be increases. And last point of these physical properties is that all these 16 elements shows allotropy. All these 60 elements can possess the allotropic in nature. Instead, all these elements can show the allotropy. So this is the physical properties of the 16 elements point. Here, physical properties becomes completed.